So thank you, Chris, for your presentation. I see you online here. So you're already unmuted. Yes. So I don't see any written questions in the chat. Matthias, do you see some raised hands?
Actually, there's no raised hand, but actually, maybe actually I can just ask a question. I think basically, if I look into the field, and I guess you see the same thing, that what is ahead of us in making data fair and making things reproducible, and what you discussed is an enormous amount of work. And actually, most people really have not realized that. Particularly in the experimental field, and I see that very often a lot of the relevant data are not even measured, right? And to build really this workflow is still actually not complete. I mean, we had this talk by Annette Trunschke where she described this for catalysis. How much details you additionally need to measure to have something which is fully reproducible. So do you see what way or what approach would you see that we convince our community that, because people have to change, right? And so how can we do this?
Yeah, I think there's always the question, I hope you can hear me.
Yes.
Yeah, okay. There are different indicators why that is changing. The first one was, for example, there was a big SFB, that's a big coordinated program, and it was in competition with another one from the same university. And one of the reviewers asked, do you have any plans in your central data repository to do that in a structured form? And they said, well, it's a repository, everybody can do it as he wishes or she wishes. And in the end, they said, okay, this is not enough. You know, there's the NFDI coming up and so on. There are ideas out there how to do it better and how to connect all the data. And that broke that part of the SFB in the proposal, in the defense. Yeah. And that means they went into the Senate of the German Science Foundation without a data plan. Yeah. So this is a cultural change, and I fully agree with you. But there's also, as soon as the ideas are out there, people will follow it. So, and what Ferdi does, and also other consortia are doing, I think people realize this can be done. And I think one of the things also which helps is that there is money now for this bringing things together. What is really missing is, if I ask my postdoc to publish his Python code, there's now GitHub and everything, but still in material science, especially if you go more to the engineering side, you don't get scientific credit for it. Yeah. And then my postdoc says, well, let's just write that paper and I do the code later on, which he never does. Yeah. And the same is true for my PhD students and so on. And I cannot agree less for them, because they don't get the PhD for contributing to this infrastructure, right? Now, I want to remind everybody, and that was funny for me because somebody told me, well, the last, let's say, big prize, Nobel Prize, was on AFM. That's a technique. And the thing is, this technique has such a big impact in our understanding of the atomistic basis. Yeah, and that kind of made me thinking, okay, maybe there are other things where we can measure impact in the future, and we have to follow that up. And then I think the contribution will be there. So it needs to be something in between an understanding I put into the discussion of my paper, and then all the path. How did I get there? If I can cite that, then I think it will change. Yeah.
So we have one more question in the pipeline. It's by Jim Warren asking, what is the status of the ontology? And if there is one, what tools have been developed that use the ontology?
Yeah. Thank you very much. I mean, I could easily give that to Luca, but I think he's also here in terms of the EMO, European Materials Ontology. That's one approach. The other approach we take at the moment is rather being very hands-on. So we have from different institutions, we try to put together teams on specific questions like mechanical properties, but also to formalize a tensile test. Yeah, and we try to work with the DIN so that it's also in some way being normed at some point. Yeah, and there's always the difference between, let's say, a very rigid and fixed workflow I have to follow in the DIN norm, and a very open, let's say, way of doing a tensile test in a scientific way, because I want to change things and try to understand. But the description, that's what we're trying to come down to make it more clear. Now, one example, if I tell anybody that we call strain epsilon, all the physicists say, no, no, this is the dielectric constant. And this is one of the troubles we have. Yeah, there's only so many variables and stuff like that. So being between physics and chemistry and mechanical engineering, we have trouble to get all the different things together in a language everybody can understand. And that's what we're at the moment more or less working on, is let's say, definitions and descriptions and dependencies without a formal description of by an ontology. I would also make the point that, let's say, materials, if they are a high dimensional space in one direction, engineering is orthogonal to that. But we meet, let's say, Young's modulus or temperature for process or anything like that. That's important for the process, for the infrastructure, and so on. And if we don't know about the oven they used, I don't know what the heat capacity of that oven is, then I cannot interpret the nominal temperature and so on, what it means for my part. Yeah. So this is what we try to do, and this is the state at the moment. We hope we will be further down the road next year, because there are a couple of projects in Material Digital starting. We have the selection is over, and I think there will be at least 8 projects, maybe 12 or 13, we will see, in the range of 2 to 3 million euros each. So there's some performance behind it, and we will see. They all have to describe that, and then we make it more like an application ontology. So everybody describes it for a specific case, and then from that we try to build it up. We are in discussion with NIST and others how to connect all that. We'll see how that works out.
So we are running a bit out of time, but there's a very interesting question, and I really ask you for a very short answer.
Okay.
So concerning the publication of code together with papers, would the code also be peer-reviewed, and who would do this?
Yes. Big debate about that too. Yeah, we have had a lot of discussions on that. We believe it's more like an exploratory way to go with it. I think we would probably adopt the way it is done in informatics with GitHub, so that you can propose a code which describes how something happens, and then people are allowed to take it and make forks out of it. And actually, I was in just one of these selection teams at the university for the informatics guys, and it was applied informatics. And the question was how many forks were done from a specific algorithm, and that was the impact, and not how many papers they wrote, because that really meant a lot of people used the idea behind it. Yeah, and that's similar to what we have in material science or in physics also. Somebody has a model, a description of a mechanism, and formalizes that with an equation or anything like that, and other people pick it up and use it either to explain what they see or to enhance it. Yeah, and I think that will probably also happen to code. But the informatics guys, interestingly, have no NFDI, where they formalize the description of code and modules. So I don't know. I hope they do it, because we need it.
So thank you. The question was, by the way, by Moritz to Barben, which I wanted to remind. So I think we have to stop here. Thanks again, Chris, for your stimulating talk, and in the interest of time.
Great conference.